Hello, this is function lesson 3. In this I will discuss number of functions from set A to set B. Now first question is find the total number of functions from set A to set B given that number of elements in set A is 3, number of elements in set B is equal to 5. So this A set will be act as input, B set will be act as output. Number of elements in A you can see that 3. So I am taking this is 1 A B C. You can take this. Number of elements in set A is 3 A B C. This is 1 2 3 4 5. Now we need to find the total number of functions from set A to B. This is the input or domain set and this is the codomain set. Now in books it's very confusing to find the total number of function, but I will tell you the simplest method. Number of f, number of function from set A to B. Number of function from set A to B is simply means that number of ways of putting balls into boxes. If you do like this, you will never attempt a wrong question. Number of ways of putting balls into boxes. The input set you can take it as balls. Our codomain set you must always take boxes. So now what the question becomes, question is now not in the function, question is the number of ways of putting 3 different balls into 5 different boxes. Now the question becomes not of function, question becomes number of ways of putting 3 different balls, that is ABC, into 5 different boxes, that is 1 2 3 4 and 5, and that is the question. The question is changed. So this kind of question are a perfect example of mix. This question is a mix of function as well as permutation. If you don't know function, you can't solve this question even if you know the permutation. If you know the permutation and combination but don't know the function, still you can't solve this question. So in order to solve this question, a student must be aware of both the chapters basic concept, that is functions, as well as the permutation and combination. So number of ways of putting 3 different balls into 5 different boxes. Now in this case we will never attempt a wrong question. Why so? Because when I say number of ways of putting balls into boxes, your input becomes balls and output become boxes. So this kind of scenario we will never apply. This situation will be not possible when we take balls and boxes, because ball number A can't go in 2 boxes. So this process will automatically be avoided because this will not make a function. So we will not count this. So whenever we take balls and boxes, so this situation will always be avoided automatically. When we take balls and boxes, this situation will always be avoided. We have to avoid this situation because this will not make a function. A function's definition is that each and every input must have a single output. Here you can see that A input gives 2 outputs. So this we have to avoid. Once you take balls and boxes, this would automatically be avoided. You can't put ball number A in 2 boxes. One ball can't be put into 2 boxes. So this will automatically be avoided. So once we take balls and boxes, we will always reach the correct solution. Now let's find out number of ways of putting 3 different balls into 5 different boxes. Now take the ball number A. Ball number A can go to any of the 5 boxes. Ball number A, B and C. Now ball number A can go to any of the 5 boxes, so we can put the ball number A in any of the 5 boxes. Now I'm just taking example. These are my 3 balls and these are my 5 boxes. Ball number are A, B and C. Boxes are 1, 2, 3 and 5. Now my ball number A can go to any of the box. Let's say ball number A goes to box number 2. So how many options we have? 5. So ball number A have 5 options. You can put the ball number A in any of the box. Ball number B, again 5 options. You can put the ball number B in box number 1, 2, 3, 4 and 5. Let's say ball number 2 B also goes to box number 2, also possible. So ball B have also 5 options, 5 choices. And ball number C have also 5 choices. Ball number C can also go to box number 2. It will be a function because all the input have a one output. So this will function. So ball C can also have 5 choices. So let's say one of the choices is ball C goes to box number 4. So again 5 choices. So total number of functions would be 125. Very important question. This question is a perfect mix of functions and permutation and combination. Question 2 is total number of functions from set A to set B. Given that NA is 5. Now we have 5 balls. A set, that is the input set, and B set. A set had 5 elements. So 5 elements could be A, B, C, D, E. And B has 3 elements, that is you can say 1, 2, 3. It means I have now 5 different balls, that is the input set, and 3 different boxes, that is 1, 2, 3. Now number of functions will be number of ways of putting 5 different balls A, B, C, D, E into 3 different boxes 1, 2 and 3. Now again ball number A have 3 choices. Ball number A can go to box number 1, box number 2 or box number 3. So ball number A have 3 choices. Same way ball number B have 3 choices. So each ball have 3 choices. So total number of functions would be 3 raised to the power 5. That is 243 will be my final answer. So number of total functions from A to set B, where number of elements in set A is 5, number of elements in set B is 3, will be 243. Now we can see that by taking the input set as balls and output set as boxes, we can easily solve these kind of questions. Now question 3 is find the total number of 1 function. Now this is specify 1 function from set A to B. A has 5 elements and B has 3 elements. Now A is the input set and B is the output set. Input set has 5 elements. If 5 balls I am taking A, B, C, D, E. And B has 3 elements. I am taking boxes and 1. These are the balls, these are the boxes. Now 1 function, you know that the definition says that each input have its own unique output. Now is it possible that 5 different balls I have I can put into 3 different boxes such that each and everybody have a unique output? It is not possible, because say if for example ball number A can go to any of the 3 places. I am taking ball number A, I am checking choices A, B, C, D, E. Now ball number A can go to have 3 choices. It can go to 1, 2 or 3. Let's say ball number A goes to 2. It has 3 choices. Now for ball number B, there are 2 choices. We have to make 1 function. Very important. Now ball number B can't go to box number 2, because 1 function simply says that each and every input should have a unique output. So 2 balls can't go to same box. So ball number B have 2 choices. Let's say 1 or 3. So ball number B goes to box number 3. Now ball number C, B and done. Ball number C. Now ball number C can go to either box number 1. Only option left is box number 1. Now the 2 balls are left, D and D. Now D and E ball must be have to put in some of the boxes. You can't keep this empty. They can't be empty. You can't keep this empty, because the basic definition of function says that each and every input should have a output. So you can't keep this D and E empty. You have to make it function. So definitely D will go to one of these boxes. Let's say D goes to 2. So this will not be a 1 function. You can't make a 1 function. That will not be a 1 function. So what the question says that total number of 1 functions from set A to set B, you can't make. So answer is 0. 0 total number of functions are possible when number of elements in A are 5 and number of elements in B are 3. Question 4 is find the total number of 1 functions from set A to set B. A has 5 elements, your A has 5 elements and B have 8 elements. So A set and B set. A set has 5 elements. You can take balls A, B, C, D, E. Now you try to solve yourself, then look at the solution. Every student, please try to solve this question yourself, then look at the way I have solved. B are the boxes, 1, 2, 3, 4, 5, 6, 7 and 8 boxes we have. Now these are the balls, these are the boxes. Whenever you need to find the function from set A to B, input set you can take as balls, this is the input set, and output set you can take as the boxes, or codomain set you can take as boxes, not output set. Now 1 function, the basic definition of 1 function says that each and every input should have a unique output. Can I say ball number A? Ball number A, I'm taking ball number A. In how many ways ball number A can go? Ball number A can go to any of the 8 boxes. So ball number A have 8 choices. Let's say in one of the case ball number A goes to box number 4. Now no other ball can go to box number 4 because we have to make 1 function. Ball number B have 7 choices. Apart from box number 4, ball B can go to any of the box. So ball B have 7 choices. Let's say ball number B goes to box number 1. Now ball number C ball number C can't go to box number 1 as well as box number 4 because they are already filled, and if it is possible then it won't be a function, 1 function. So ball number C have 6 choices. So let's say ball number C goes to box number 6. Ball number D has again 5 choices. It goes to box number 3, and ball number E have 4 choices. So answer will be 8 into 7 into 6 into 5 into 4. So you can see that 5 4s are 20, 20 into 6, 120 into 56. That will be your final answer. So that was all about lesson 3. In the next lesson, I will continue with more on number of functions from set A to B. Thank you.